Welcome to Covid-eos, where we explore the maths and the models describing the COVID-19 pandemic. In our first video of this series on CovidSim, we gave a very brief overview of the mechanisms involved. In the second video, we're going to look in much more detail at how individuals in the model interact with others and at how well this captures real life. Previously, we saw that our little character, Bob, came into contact with a range of individuals, some infected and some not, and as a result of this became infected himself. But how does CovidSim know who Bob is likely to meet and come into contact with? We all have groups of people we see more regularly than others, and it's unlikely that we're going to be infected by someone who lives on the other side of the country. One reason CovidSim is so complex is because of the amount of real geographical data used to set up the model. For each individual like Bob, we're going to use UK Census data to give him a county to live in. Here, it turns out Bob's from Somerset. But Somerset's still quite a big place, with nearly 1 million individuals, so CovidSim goes to an even smaller scale. This map shows the county parishes of Somerset, smaller areas which subdivide each UK county. In this example, we're going to say that Bob lives here, in Burnham-on-Sea. Like most of us, Bob has to work, and his job is based over to the west, near Exmoor. CovidSim used UK Census data to put the right number of people in each town or village and to choose a workplace a sensible size and distance away for them to work in. This is great and gives Bob a bit more of a realistic backstory, but how is this information used in the model? When considering infection events, we know that people Bob comes into contact with more often are more likely to infect him. So CovidSim therefore is going to store a list of people that it thinks Bob is likely to meet up with. In this scenario, Bob lives with 2 other people, and if one of them is infected, it's quite likely Bob will also get infected as they live in the same place in close contact. We can call these infections a household type. Similarly, CovidSim knows which people work in the same place as Bob, and these people also have a higher chance of an infection event. If Bob was younger, this workplace might represent a school or university. Aside from home and work, Bob can be attached to a couple of other local places he attends regularly, which maybe represent a kayaking club or his local shopping centre. People that are also associated with these same places are known to be more likely to have contact with Bob and therefore infect each other. We'll call these local place infections. Finally, we're not going to trap Bob just in Somerset, however nice a county it is. Maybe Bob's got friends in other neighbouring counties and beyond that he might be likely to meet up with. It's much more likely that Bob sees people from nearby Devon than at Dundee in Scotland, but it's not impossible. CovidSim therefore allows for interactions with people from different counties, and those who live closer to Somerset are more likely to come into contact for these other county infections. With this amount of geographical detail, CovidSim was able to model non-pharmaceutical interventions very effectively. Work/school closures stop Bob interacting with his work colleagues, and larger lockdowns would prevent him meeting with friends in other counties. Both these measures would reduce the number of people Bob is likely to come into contact with on a daily basis. CovidSim could also look at digital contact tracing apps, such as the one used in the UK by the NHS, and these would keep track of Bob's contacts and put him in a house lockdown if he interacts with an infectious person also using this app. Now we've seen in more detail exactly how CovidSim uses UK Census data to make the model more realistic, and how small changes to the model can be used to simulate non-pharmaceutical interventions like lockdowns. Despite all these measures, unfortunately Bob does become infected, and so in the next video we're going to take a closer look at the progression of his illness through to his recovery.